Warm greeting to all. Now we are going to discuss 5-step method. That is step 1, clarification. So clarifications the problem, concept generation, example power nailer. So we are going to create a power nailer. We are going to create a concept for power nailer. So what are all the problem existing in the previous nailer? So that we have to identify the problem and you have to give a concept, new concept. So this nailer eliminates the hammering on the nail. So that we are going to eliminate and we are creating a new concept. See this, design a better handheld roofing nailer. So we are creating a roofing nailer, handheld roofing nailer. The scope of the design problem could have been defined more generally. Example, fasten roofing material. Fasten roofing materials. So we are fasten the roofing materials, or more specifically, example, improve the speed of the existing pneumatic tool concept. So we are eliminating the pneumatic tool concept as well as the hammering on the nails, so that we are going to eliminate and we are creating a new concept for nailing. Some of the assumptions in the team mission statements were the nailer will use nails as supposed to adhesive screws, etc. So we have to nail. The nailer will compatible with nail magazines on existing tools like hammer or pneumatic tool concept. The nailer will nail through roofing shingles into woods. Woods are also we can nail. The nailer will be handled, so it will be handy one. So whenever wherever we can carry the hand nailer. Based on the assumptions, the team had identified the customer needs for the handheld nailer. These includes, so the customer requirements of the hand nailer. The nailer insert nails in rapid session, so continuously you can nail through this machine. The nailer is lightweight. The nailer has no noticeable nailing delay after tripping the tool, so we need to do continuous nailing. So these are the three important parameters the customer wants to require on the nailing process. The team gathered supplemental information to clarifying and quantifying the needs, such as approximate energy and speed of the nail. So, what is the energy required to nail the um, nail on the wood on roofing, that we have to analyze, and the speed of the nailing. So, how much speed you can feed the nail, that you can identify. These basic needs were subsequently translated into target specification. So these are all comes under target specification. So what are all the specifications required for the machines, so that we can derive nail length from 25 millimeter to 38 millimeter, and maximum nailing energy of 40 joules per nail. The nail forces of up to 2000 newtons, peak nailing rate of one nail per second, average nailing rate of 12 nails per minute. So 12 nails we can feed per minute. Tool mass less than 4 kilograms, maximum trigger delay of 0.25 seconds. So these are the specification we derived from the existing data one. Then problem decomposition, the function diagram. So the input energy, how much input energy required, so what are the materials we used, and what is signal tool trip, that is what is the time between one nail to another nail. So this is a hand nailer, then we are getting output, material is driven nail, then signal. So what is the signal we are giving, we are getting, right? So these are the energy nails trip of tools. So we have to decompose each and every one, that is energy. What are the energy? So nails, what is a nail? And trip of tool, so how to do trigger, so that you have to segregate, that is we call it as problem decomposition. Each and every one you have to study before generating the concept. So store or accept external energy, so we are converting the energy to translation energy. We are nailing on the wood, so translating energy is required. Apply translation energy to nail and driven nail. The nails stores nails in a nailer, then continuously feeding the nail uh, through wood piece, that is it is also a translation motion. Then trigger of tools, sense strip and triggering tool. So every nail come after come out, it will take zero point 0.2 seconds to another nail has to come. So this is triggering. So this is also in the translation energy. So we'll get the driven nails. So next, the two approaches, that is decomposition by sequence of user action. So what are all the user action? So moving the tool to the gross nail position. So you have to move the tool through gross nail position, positioning the tool precisely, triggering the tool. So continuously are feeding the tool. So this is decomposition by means of user action. So decomposition by key customer needs. So what are all the customer requirements in a nailing? So fire nails in rapid session. So continuously we feeding the nails. Then it should be a lightweight and it has large nailing capacity. So we need a large nailing capacity. This approach is often useful for products in which form and not working principle or technology in the primarily problem. The examples, some examples is given of such products includes toothbrushes, assuming the basic brush concept is retained. So we in earlier days we are using a neem stick for teeth. So this concept is uh, used in toothbrushes. So this is a simple example. So this is about the clarification of problem. So we are clarifying the problem, we are to generate a concept. So next class we will discuss in the next step of the concept generation method. Thank you.